this video we're going to look at transforming graphs by a variety of different ways. There's two main ways that we can transform graphs. We can either change the x values or we can change the y values. This little cheat sheet that's on the screen now just gives you a general overview on what you're going to have to do. If you notice, when the changes on the inside, you're going to do the opposite of the x value. So for example, f of x minus 5, you're going to add 5 to the x's. F of 2x, you're going to divide the x's by 2. When it's on the outside of the function, not inside the parentheses, we're working on the y value. And you do exactly what it says. So unlike the f of x minus 5 changes to x plus 5, f of x minus 2 becomes y minus 2. And the 2 times f of x becomes 2 times y. So pause the video now, write these notes down because they're going to come into play on every other problem that we're going to do from this point forward. Okay, so now we're going to start to look at some problems. This problem is y equals f of negative x. So the negative is inside the parentheses with the x. So that means we're going to work with the x values, not the y values. So the first thing we're going to do is always write down our starting points. So my starting points in this one is negative 4, 4, and 4, 2. And now I'm going to do my transformation to it. So if we look, I'm going to change the signs of my x's. So if it's a negative, it's going to become a positive. If it's a positive, it becomes a negative. So if I look, my negative 4, 4 becomes positive 4, 4. And my negative 4, negative 2 becomes negative 4, 2. Now I'm going to graph those 2 points. So I go 4, 4, and negative 4, 2. And I connect the dots with a line. And there's my answer. In this problem, you notice that the negative sign is outside of the parentheses in front of the problem. So that means we're going to be looking at the y value and not the x value when we're changing my signs. So I've got my 3 starting points, negative 4, negative 5, 4, negative 1, and 7, negative 4. And then I'm going to change my y values. So all my y values are now going to become the opposite. So this was a negative 5, so it becomes a 5. Negative 1 becomes a positive 1. And negative 4 becomes a positive 4. Notice that my x's did not change. I'm now going to graph those 3 points. So I've got negative 4 and 5. And then I got 4 and 1. Then I've got 7 and 4. I'm now going to connect those with lines, and my problem will be finished. Do make sure you connect them to the right points, otherwise the picture doesn't look right, and it will mark you wrong. Okay, now this problem, notice that we have a 2 inside the parentheses instead of a negative sign or anything else. Now, if you remember back to the cheat sheet at the beginning, we're doing whatever the opposite of whatever is inside the parentheses. So in this case, since it says times 2, I'm going to multiply by 1/2 or divide by 2. It's the same thing. So as you can see here, I'm going to do 1/2 x. So I'm going to take all the x values and cut them in half. So that negative 2 becomes a negative 1. The 0 stays a 0, and that 2 becomes a 1. Notice the y's do not change. So now I'm going to graph these 3 points. So I've got negative 2, negative 1, negative 4, which is right there, 0, 0, and then 1, 4. And again, connect my dots with lines. And I have my answer. This 1/2 is outside the parentheses, which means I'm going to be doing it to the y values. And I'm going to actually do exactly what it said. I'm going to multiply the y values by 1/2. So we have 1/2 y, so the x stays the same, so that's negative 4, and the y gets cut in half, so that's 2. And the 0, 0 stays the same, because 0 times 1/2 is still 0. So I'm going to graph those 2 points. So I got -4, 2, and then 0, 0. And then we connect my dots. So in this case, I only have 2 points, so I only have to do 2 points of work. In this equation, you'll notice that I have the 1/2 inside the parentheses next to the x. And if you remember the last one we did when it was a 2 inside the dx, we did the opposite of it. And the opposite of multiplying by 2 was multiplying by 1/2. Well, in this case, the opposite of multiplying by 1/2 is multiplying by 2. So we're going to do 2x. So 0 stays 0. The 4 is going to become an 8. So I have 0, 0, and 8, 4. I'm going to graph those 2 points. So I have 0, 0, and 8, 4. Connect those to the line. And I have my graph. In this function, I have the 2 outside. So I have 2 times g of x, which means I'm going to be changing the y's and multiplying them by 2. So I have my 3 points, -2, -4, 0, 0, and 4, -2. And I'm going to multiply all the y's by 2. So that -4 becomes a -8, 0 stays a 0, and the -2 becomes a -4. So I'm going to graph these 3 new points. So I have -2, -8, 0, 0, and then 4, -4. Connect those with lines. And there's my new graph. And the next 4 problems are going to be the more complicated ones. This is the last topic in the list, and it's because there's 2 transformations I have to do to each graph. You'll notice in this problem, highlighted above, I have a 2 on the outside, and I have a -1 on the inside. So I'm going to multiply the y's by 2, and then I'm going to add 1 to the x's, because remember I did the opposite. I'm always going to work with my x's first. So the first thing I'm going to do is write my 3 points down. So I have -4, 0, -2, -4, and 0, 0. And now I'm going to add 1 to the y's, or to the x's. So I have -3, 0, -1, -4, and 1, 0. So notice I just added the 1 to the x's. That takes care of the inside. Now, on the outside, I have the 2. So I'm going to multiply all my y's by 2. I'm going to look at the new 3 points that I have. So that 0 stays a 0. The -4 becomes a -8. And that 0 stays a 0. So my 3 points that I'm going to graph are -3, 0, -1, -8, and 1, 0. So we're going to take this point. So I got -3, 0. So that's right there. -1, -8, and then 1, 0. And then we connect those with lines. And I have my new graph. In this problem, I have a -x, and then I have a -3 on the outside. So the first thing I'm going to do is write down my 3 points, -2, 4, 0, 0, and 4, 2. And then I'm going to work on my x's. So I have -x. So that -2 is going to become a +2. 4 stays a 4, 0, 0. That +4 becomes a -4, and the 2 stays. Now, my y was -3. So I'm going to take 3 away from all my y's. So it becomes 2, 1, because 4 minus 3 is 1. 0, -3, because 0 minus 3 is -3. So the 0, 0 does not always stay the same. It works when we're in multiplication, because zeros don't times multiply stay the same. And the -4 and 2 minus 3 is -1. So my 3 new points, the ones I'm going to graph, are 2, 1, 0, -3, and -4, -1. So I'm going to graph those 3 points. So 2, 1, 0, -3, and -4, -1. And I'm going to connect those dots. And that's my new graph. In this problem, my 2 transformations is I have a 2 times x in there, so I'm going to do 1/2 times x. So remember, I always do the opposite of the x's. And then a +4 on the outside, so I'm going to add 4 to my y's. So the first thing, always again work with my x's first. So I'm going to do 1/2 x, so that -4 becomes a -2. The -2 becomes a -1, and the 0 stays a 0. Now I have +4 on the outside, so I'm going to add 4 to my y's. So I get -2, 4, -1, 0, because -4 plus 4 is 0, and then 0, 4, because 0 plus 4 is 4. I'm going to graph those 3 points. So I have -2, 4, -1, 0, and 0, 4. I'm going to connect my dots. And that's my graph. This is the last problem we're going to look at. Now this one's slightly different than the other ones because this one does have 2 transformations, but they're both to the y's. So if you notice, there's nothing inside the parentheses with the x. So I have a 2 times on the outside, and I have a -4. Whenever you have multiple things done to the y, you do them just like the order of operations. So I'm going to do the times 2 first, and then I'm going to subtract 4. So you'll notice the first thing I have is write my 3 points down, 0, 0, 2, 4, and 4, 0. I'm going to multiply my y's by 2, so the 0 stays a 0, the 4 becomes an 8, and the 0 stays a 0. And now I'm going to subtract 4 from each of those points. So 0, -4, 2, 4, yes, the point does go back to the same point I started with, but that is okay. And then I have 4, -4. So now I'm going to graph these 3 points. So I have 0, -4, 2, 4, and then 4, -4. And I connect my lines. And I have my new graph. Hopefully this video helps you do the transformation graph problems in ALEKS. If you have any other questions, feel free to email me. Thank you. Bye-bye.